All right, today we're going to discuss an application of the Pythagorean theorem. Recall the Pythagorean theorem states that if a triangle is a right triangle, then the square length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. The converse of the Pythagorean theorem is also true, and that would say that if any triangle has that relationship between the sides, the square of the length of the hypotenuse is equal to the square of the length of the other two sides, then we know the triangle is a right triangle. We're going to see an application of the converse of the Pythagorean theorem today. So this problem we're going to call tiling with Pythagoras. Carpenters and floor installers often use the Pythagorean theorem or its converse to achieve accuracy in their projects. We're going to consider today a simple floor tiling project. Suppose we're tiling the floor in a room of our home with 7 3/4 inch square tile, and we want to make certain that the layout of the tiles is square. Using the converse of the Pythagorean theorem, we're going to describe a practical and easy method to square up our floor tile layout. We'll assume we've measured and marked the center of our room using a carpenter's square. That is, we've drawn two perpendicular lines on our bare floor that intersect at the center of the room. So we're using natural stone tiles that are 7 3/4 square, and we're going to assume we're laying out our tiles in a tight pattern without grout lines between them to simplify the problem. Here's a picture of our natural stone tiles. Notice that they're slightly rough on the edges, but each one does measure approximately 7 3/4 inch square. So we begin by lining up 3 of these floor tiles on our floor, meeting at the center mark, the intersection of those two perpendicular lines we've drawn on our floor. When we line up 3 and each measures 7 3/4, the total length of these 3 now is 23 1/4 inch. Next, we'll arrange 3 more tile perpendicular to these first 3 as shown. And 4 times 7 3/4 would say that the length of this side is 31 inches. Now, we would draw the diagonal as shown from one corner to the other of this array of tiles. And the question is, how long is this diagonal length as we've currently laid out our floor tiles, and how long should it be? We're going to use the converse of the Pythagorean theorem to determine how long this diagonal length should be. So let's refer to the length of the 3 tiles as side A, and that was 23 1/4 inches. And let's refer to the length of those 4 tiles as side B, and that was 31 inches. So applying the converse of the Pythagorean theorem, we square the length of side A, we add that to the square of the length of side B, and that should equal the square of the length of the diagonal as we had drawn. So now we solve this for the length of the diagonal, and we find that it should satisfy 38 3/4 inches. So the diagonal length should measure 38 3/4 inches if our floor tile pattern has been laid out square. So you can now go back to where you've laid out the floor tile on the floor, you measure the length of the diagonal, and if it's not 38 3/4 inch, then we adjust the layout of our tile slightly until it is as close to 38 3/4 as we can make it. Now, if you were writing this out for a solution to a mindscape, what all would you need to include? I would suggest you include a sketch of the actual array of floor tiles, write the length of the 2 legs, and draw in the diagonal, and then include the arithmetic where you use the converse of the Pythagorean theorem to solve for 38 3/4 inches, and then a couple of sentences. Wrap it up with a couple of sentences where you explain how you'd use this measurement 38 3/4 to adjust your floor tile out as needed. Thank you.